We just defined the group algebra of a finite group G by saying that its elements are linear combinations of the group elements. So we write a Q in the group algebra as a sum over G in the group and some coefficients QG times G, complex coefficients. And now let's take a second element in the group algebra, say R, coefficients RG. Clearly we can add these elements here by just doing component-wise addition. So this is a vector space, we have a vector space structure. And now we also want to define a multiplication. And that we can do as follows. We just write them next to each other. So there is Q, QG, G, and then there is R, but now we have to give the summation index a different name, so we sum over G prime in G, R, G prime, G prime. So this is just a double sum, G, G prime in G, Q, G, R, G prime, G, G prime. And now we use the group law here. Then G times G prime is some group element. So this is in the group. And this means, if we define it like this, and the whole thing here is again a linear combination of group elements, complex coefficients. So this is in the group algebra. And by this we have a multiplication law for elements in the group algebra.